What's up everyone, welcome back, Patrick here. In this next question, we are given the demand and supply formulas below for a product over here, where P is the price per unit of the product, and then X is the number of units of the product. And they're asking what will the equilibrium price and quantity be? And when they're asking for the equilibrium price and quantity, that's an economic term of where the demand is equaling the supply. Right? So we basically have to find the point of intersection between these two functions. So another way this could have been worded is, when is the demand and the supply going to equal? For what price, for what p-value, and for what number of units? So we're going to algebraically solve this, but just to give you a visual of what's happening quickly, it's not essential, but just in case you want to make sense of these functions here, notice that this function, this demand function, P equals 1400 over X, notice that that's a reciprocal function. If you remember from high school functions, so if we let this be P, this is the X-axis, so 1400 over X is going to look something like that. There's actually another portion over here, but because this is a word problem and we know that the price has to be positive and the number of units has to be positive, those can't be negative, this is the only portion of this function that we're going to be dealing with. So that's the demand function, and then this supply function, this is just a line over here. So this x over 200 we can rewrite as 1 over 200 x plus 3 over 10. So notice this is in y equals mx plus b format. Right, so 3 over 10, that's a positive, so let's say that's like over here. And then we have a positive slope, so this line is going to be like that. So this is the demand function. This is the supply function, it's just a line, and we have to find this over here, the intersection between them. That's going to be the equilibrium. And more specifically, we have to find the number of units at this point, and then the price at that point. So that's what we're doing just from a higher level. So how do we find that specific point? Well, there's actually multiple ways you can go about this. What I'm going to do is I'm actually going to make both of these equal. So notice P is equal to this, P is equal to that, which means 1400 over X equals X over 200 plus 3 over 10. And then different steps you could take here. What I'm going to do is I'm actually going to combine this side into one fraction. And then once we have one fraction on this side, we can then cross multiply. So to combine it into one fraction, we need a common denominator. So we can multiply the 10 by 20, which means we have to multiply the 3 by 20. And so we can rewrite this as x plus 60 over 200, like that. And then from here, now we have one fraction on each side. Notice how this is the exact same thing as this, but now we can cross multiply. So notice we'll have x times, so bringing this over here, we'll have x times x plus 60 equals 1400 times 200, like that. So we'd end up with x squared plus 60x is equal to, this would end up being what? 280,000? Like that when we multiply them. Then we could bring the 280,000 over. And now notice that we just have a quadratic equation. So multiple things you can do with this quadratic equation over here. You can plug it into the quadratic formula. Notice the A value is 1, the B value is 60, the C value is negative 280,000. This actually, in fact, factors smoothly. What it's going to factor into is x plus 560 and then x minus 500. like that. But when you're dealing with big numbers like this, even if it factors smoothly, it may take you longer to factor it versus just putting it into the quadratic formula, right? But it does factor smoothly. 560 times negative 500 gives us negative 280,000. Then 560 plus negative 500 is that b value of 60. And so from here, we could tell the solutions either x plus 560 is equal to 0 or x minus 500 is equal to 0. So we get negative 560, and then we get positive 500. But the negative, because we're dealing with this word problem, we know x can't be negative, we would just ignore that. So this x value here is coming from that other part of the graph that I drew earlier, because this line keeps extending, but again, we're just looking at the first quadrant. And so x is equal to 500. And so that's the equilibrium quantity. And then if you want to get the corresponding equilibrium price, we could just take that 500, either plug it in here or plug it in here. Both are going to give us the exact same solution. So let's just plug it in here. I feel like this one's easier to use. 1400 over 500. And then notice we could divide both the numerator and denominator by 100. So this would simplify to 14 over 5. And then if you want to change this to decimals, this would be 2.8, so $2.80 would be the equilibrium price. So that would be over here. All right, and then that's the answer. So the equilibrium quantity is 500 units. The equilibrium price is 280. Right, so multiple ways that you can go about solving this. You didn't necessarily have to do it this way, putting this one fraction, then cross multiplying. That's how I did it. Another potential way you may see this shown, just to show you how you can get to the exact same spot, is at this point, they may just multiply everything by the lowest common denominator. So notice the lowest common denominator between x, 210 would be 200x. So we'd multiply this by 200x, multiply this by 200x, and multiply this by 200x. So what would happen? The x's cancel out. This times this gives us 280,000. The 200s cancel out. X times x is x squared. And then 10 goes into 220 times, so we'd have 3 times 20x, which gives us 60x. Then bring this over, notice we end up at that spot. Right, so that's another way you can go about it. Personally, if I get something like this, I like to change it all into one fraction on each side, and then just cross multiply. But whichever way you do it, the equilibrium quantity is 500, the equilibrium price is 280.